Namaste and greetings to all of you. On behalf of the Energy and Resources Institute, TERI, I welcome you all to the World Sustainable Development Summit, the only independently convened summit of this scale in a developing world that brings together world leaders on a single platform. We thank you for joining the plenary session on meeting the twin goals of energy and resource security. As markets go bullish on clean energy technologies and pressures mount to move away from fossil fuel energy systems, governments across the world will intensify their efforts to deploy renewable energy technologies. However, inconvenient questions should be asked on aspects concerning availability of resources, including critical minerals and life cycle approaches to renewable energy technologies. To that end, this session is aimed to be a critical reflection on the present narratives around energy transitions from the perspective of resource security. With this, I now have the honor of inviting Mr. Suman Berry, who is also on the WSDS International Steering Committee, to moderate the discussions. Mr. Berry is an accomplished economist and academic. Mr. Berry was recently Shell's chief economist based in The Hague. He is currently a non-resident fellow of the Brussels think tank, Bruegel. Over to you, Mr. Berry.
Thank you, Shelley. Am I live? Thank you very much, and let me, thank TERI for once again involving me in this very important and exciting event at a critical time, and allowing me the privilege of chairing such an illustrious panel on an important topic. You have already signaled what the core issue is here, which is essentially, is there a conflict between the issue of energy security, and the focus here will be decarbonization in energy rather than in other areas, and resource security. I would just, before handing over to the first speaker, just say, as an economist, I'm always skeptical of the idea of shortage. I think if you let markets work, then shortages have a way of correcting themselves. So I think it's not only going to be about physical constraints, it's going to be about geopolitical constraints as well. And I do hope that our illustrious speakers will acknowledge that this is both a technical issue, but also a political issue. With that, let me call upon the first of our speakers, Lord Turner, Adair, as he's asked to be called, who I've had the pleasure to know from my time at Shell, because I happened to be there when the first stirrings of the Energy Transition Commission was being conceived of. Lord Turner is, in addition to being chairing the ETC, he is a senior fellow at the Institute for New Economic Thinking, chairman of the insurer group Sub Europe, and on the advisory board of Envision Energy. But I think he has an earlier career in the financial sector and in consulting, and is widely thought of as one of the clearest minds in any of the fields that he works. Adair, over to you for 10 minutes, please.
Thank you very much. It's a great pleasure to join TERI's World Sustainable Development Summit again this year. I've been for many years, and I hope that next year I can be there in Delhi in person. Today's topic of natural resource supply and security to support the energy transition is a crucial one. All credible analyses show that the only route to a zero carbon economy is to electrify as much of the economy as possible and to completely decarbonize electricity supply. And as a result, total global electricity generation could need to increase 4 or 5 times, with 2 times increases even in rich developed countries, 15 times in Africa, and maybe 6 times there in India by 2050. And analyses by many organizations, including the joint ETC-TERI analysis of the Indian power system, show that such huge zero carbon power systems, based primarily on renewables, will be able in future to deliver power at costs no higher than today's fossil fuel-based systems. But inevitably, this new energy system with clean electricity at its core creates new material demands. Silicon for solar panels, steel for wind turbines, rare earths for electric magnets and motors, lithium, manganese, and cobalt for batteries. And that's why this year, as part of a detailed look at what we call all the possible barriers to clean electrification, the ETC is going to look in detail at all of the issues related to natural resource supply, from the land area needed to support renewables development to the minerals needed to support electrification. But I believe that 3 things are already very clear. First, that in the long term, there are no inherent resource constraints which could prevent massive clean electrification. Second, that any adverse local environmental impacts of new mineral exploitation will be far less than those imposed by fossil fuel extraction. Third, however, that we must manage the transition carefully. First, then, the good news. There are no inherent resource constraints. I could illustrate that for many required resources. For solar or wind resources to support that huge increase in electricity, or for the water needed for green hydrogen electrolysis, or for any of the minerals. But let me focus for illustration on one about which one often hears concerns: lithium. Lithium will almost certainly remain the crucial element in batteries. And if in 2050 there are 2 billion electric cars on the road globally, each with a 60 kilowatt hour battery, that will require a stock of lithium in those batteries of about 19 million tons of pure lithium. But economically accessible resources of lithium are currently estimated by the US Geological Survey at 80 million tons. And that estimate has increased from 53 million tons in just 2018, reflecting a familiar pattern in which once a mineral becomes more valuable, more resources are identified, which relates to the point that Suman made a few minutes ago, that market 19 million tons of lithium will probably at the peak require mining about 1 million tons of pure lithium per annum, or about 7 million tons to use. And lithium mining, if done badly, has significant adverse local environmental impacts. There is a use of toxic chemicals such as hydrochloric acid when we extract lithium carbonate from rock deposits, or there is very large water inputs used to extract it from salt flats. But however bad it is, the environmental impact of mining 7 million tons of lithium carbonate per annum is bound to be minimal compared with the local environmental impact of mining 7,000 million tons of coal per annum, which is what the world does today. Just keep those figures in mind. 7 million tons of lithium, 7,000 million tons of coal. And across all of the material inputs which we need for our future system, their adverse environmental impact at local level is bound to be an order of magnitude, or 2 or 3 orders of magnitude smaller than our old fossil fuel-based system, which is not just a happy accident, but inherent to the very nature of this new renewable system. Until now, to get energy, we have taken massive amounts of fossil fuels out of the earth each year. 7,000 million tons of coal, 36.5 billion barrels of oil, 3.9 trillion cubic meters of gas. We have burnt it in chemical reactions, which produce 30 billion tons of CO2. And then the next year, we have done the same all over again. In a renewable system, by contrast, we take much smaller quantities of inorganic minerals and we put them into structures. Silicon in the solar panels, copper in the wires, lithium in the batteries, rare earths in the motors. The photons of sunlight and the motion of the wind then generate stream of electrons, which we can use to heat or cool our buildings, to drive our machines, or to create hydrogen molecules. And at the end of the year, those structures, those wires, those silicon panels, those batteries are largely unchanged and ready to do the job all over again the next year. So it's very important not to let concerns about the natural resource and environmental impact of the new energy system slow the transition away from the far more harmful fossil fuel-based system. But it's also crucially important to anticipate and manage the challenges which the transition will bring. Mining lithium is less harmful, far less harmful than mining coal, because the quantities involved are trivial in comparison. But we will need tight regulation and sourcing commitments from the companies which source these materials in order to make sure that the adverse environmental impacts are as small as possible. 19 million tons of lithium in 2 billion cars could, with the technologies already available, be almost continually recycled at end of life, but that will only occur with strong regulation to enforce end-of-life product responsibility. Cobalt production in the Democratic Republic of Congo often involves dangerous artisanal mining and child labor. Strong sourcing standards must prevent this, alongside what is already occurring, the technological innovation which is already dramatically reducing the use of cobalt in batteries and in some cases eliminating it entirely. And major companies at the top of the key value chain, such as the automotive and battery companies, must as best possible develop on an anticipatory basis supply chains which can anticipate surges of demand, since otherwise short-term bottlenecks will produce huge temporary price surges, such as we've seen with cobalt up 40% in the last year, nickel up 30%, and lithium up several 100%. Though let's remember that the fossil fuel-based system has been equally or even more volatile in terms of short-term price cycles, with natural gas prices in Europe, Japan, and Korea rising 400% in just the last 6 months, and India hiking the gas tariff by 62% last September, with further increases anticipated. So short-term price spikes they seem to be just inherent imperfections of a capitalist system which never fully anticipates well future supply and demand, but it is applied in the fossil fuel-based system quite as much as the new system. Indeed, the great prize is that in principle, a renewable energy system could be not only far cleaner, but also more economically stable than a fossil fuel-based system. But that will only be the case if governments and companies make it so. Thank you very much for listening, and I look forward to the discussion.
Thank you very much, Adair, for covering so much ground within your allotted time. Let me just say that a couple of points struck me before I call on Janice Potarchnik to follow you. One is, how do you maintain a sense of proportion of the kind that you have articulated? Because we will be getting some stories about miners in DRC, etc. So I think the issue of communication on, as it were, the larger game is a crucial obligation. And the question is that we'll come to in the discussion is an obligation of whom? And secondly, there is the issue of rent that will arise as these markets get established. And so if you have any thoughts on, as it were, the mechanisms for the allocation of rents. Again, so that we can play the longer game. I think that would be interesting to come back to. But let me now come to our second speaker, Janice Potarchnik, who is the co-chair of the International Resources Panel, which I understand advises or was set up by the UN Environmental Programme, but prior to that has a distinguished career as an official in the EU Commission. Janice, all yours now.
Chairman, dear friends, thank you for the invitation. It's a real pleasure to participate on this important panel. And let me try to briefly address all the 4 questions you have identified for us. But being a co-chair of International Resource Panel, I apologize in advance. I simply cannot avoid addressing broader resource perspective and avoid only focusing on securing critical minerals for energy needs, since we believe that broad systemic approach is actually the essential. Current UN FCC focus is mainly addressing supply-side problems. It is focusing on optimizing, greening, cleaning the current economic model. Unfortunately, we believe that this will not be enough to meet the 1.5 degrees target. Deep system change transformation is needed and without any delay. Current efforts are to an important extent ignoring the need for a deep system change transformation, which would address also the overconsumption in high-income countries and reasons for the fact that we are already overshooting some of the planetary boundaries today. This is leading to lasting tensions among high-income and low-income countries, since real drivers and pressures are not adequately addressed. When natural resource management-related matters are discussed, like, for example, industry or transport in Glasgow, focus remains on a surface level, not really addressing the real system change solutions. For example, a Glasgow breakthrough was announced on road transport, aiming for zero-emissions vehicles to be the new normal, accessible, affordable, and sustainable in all regions by 2030. Important, but I sincerely hope this will not become a new normal, since it would not remove the core problem related to huge underutilization of private vehicles, leading to inefficient overuse of resources. Do not forget, we actually need mobility. We do not need cars. As you have heard, I'm a co-chair of the International Resource Panel, together with Isabella Teixeira. To introduce the panel in just one sentence, we are Science Policy Interface hosted by UNEP, brought together to produce new insights on the management of natural resources, its impacts and solutions. Under natural resources, we understand biomass, metals, non-metallic minerals, and fossil fuels. All mentioned are actually called materials and are extracted from the earth, as well as, of course, water and land. We know from the IRP work included in our most comprehensive report called Global Resource Outlook that extraction and processing of natural resources drives all aspects of the triple planetary crisis of climate change, biodiversity loss, and pollution with health implications included. It is responsible for 50% of the global climate change. Energy use is a significant driver of the extraction and processing. Impacts are mainly due to the production of fossil fuel products and biomass, but also steel and cement. But natural resources also causes over 90% of global land-related biodiversity loss, mainly due to agriculture, timber production, or ocean resource use, and water stress. Natural resource industries, such as steel and coal, are also behind 1/3 of global air pollution, as well as water and land pollution. We also know that the trends are alarming. Material use, which, as mentioned, compromises everything extracted from the earth, has tripled since 1970. And IRP data tells us without transformative change, it will double again by 2060. The consequences for the triple planetary crisis will be severe. Therefore, we know it is absolutely necessary to decouple growth in well-being and prosperity from natural resource use and its impacts. What we really need are systemic interventions, which would limit the need for energy and resource use in the first place. We must focus not only on decarbonization, indeed most important, but also on the need to dematerialize the systems we depend on. This is important for all, but urgent for high-income countries. I'm talking about mobility, housing, nutrition, and some consumer goods, by looking far beyond most common questions, too many times related to recycling. We need to reject the assumption that these systems need to be so resource-intensive. The most powerful instrument to deliver this transformative change, also already widely accepted, is circular economy, if only understood broadly enough. It captures incentivizing repair, reuse, recovery, and of course recycling, as well as optimized product utilization and experimentation with new business models and new ways of creating value. Instead, for example, asking how to make car industry cleaner, which is indeed very important, we should be asking also a question how we can reorganize mobility system to use less resources, and what role in that aspect private car, hopefully lighter, could play. So combining supply and demand part of the policy questions and offering even more convincing policy answers to fighting climate change. Extended producers' ownership and creating value through services rather than products, it's a very promising avenue to exploit. Diverse sectors are already benefiting from product as service models. For example, renting rather than owning a washing machine reverts the incentives. The producer remains the owner, and it is therefore incentivized to design it to last, to repair, and to extract value from product at the end of its life. The amount of washing machines produced and sold to consumers, which is currently the base for making their profits, would in that case of service provision become part of producers' cost. Instead, that they would be incentivized to use more resources, they would be incentivized to innovate, saving resources, and increase their service-related profits. In short, circular economy strategies can make a massive contribution to achieving climate and biodiversity targets through reducing demand for energy and for resources simultaneously. Second, and I will be shorter now, what are the implications of this mismatch of strengthened climate ambitions and the availability of critical minerals that are essential to realizing these ambitions on climate and energy policy? First of all, as mentioned, it's not about only critical minerals and their importance to achieve the energy transition ambitions. The importance of various materials uses for reaching climate and also other environmental targets are explained before, but they are more broader and complex. We need to refocus policy towards the systemic solutions which reduce the need for resource and energy altogether. If we focus policy only on specific improvements, we can cause unintended consequences, ignore potential trade-offs, and even create future lock-ins. We need to think the whole system when designing those solutions to maximize co-benefits. For example, limiting urban sprawl and better city design will not only reduce the resource requirements to the built environment, but it will also minimize the amount of time you need to sit in dense traffic on your morning commute and reduce the need for commute in the first place. Recent IRP work offers system solutions in housing and mobility, two systems where changing patterns of utilization, as well as making the material use embedded in their products circular, could make considerable contribution to reducing emissions. By taking this systems approach, we can turn difficult transition needs into big societal opportunities. By improving housing, infrastructure, mobility, nutrition systems, we can strategically improve their societal function, something that is much harder to do when we only look at cleaning up production. In sum, we need to decouple the function of mobility, housing, nutrition, and well-being overall from the virgin resource use and environmental impacts. However, if we look at countries' current nationally determined contributions and national climate plans, we can see that this systemic approach, despite efforts of many, including some panel members, is still missing. Third, what are the geopolitical implications of more expensive, delayed, and less efficient energy transitions, resource insecurity? Human consequences of resource insecurity are huge, including macroeconomic and political instability. The links between resource use and human well-being are, of course, critical. And in a resource-constrained world, it is even more important to ensure that the resources we use are delivering as much as possible for meeting human needs. The IRP Next Global Resource Outlook, we aim to quantify these links, measuring how the resource utilizing system we depend on are contributing to our well-being. By measuring the performance of these systems, we can unlock the opportunities to reduce resource use and its impacts, while continuing to increase human well-being around the world, especially in the first place in low-income countries. And finally,
you're in the last minute, please.
Yeah, you rightly state before your last question that resources are crucial for sustainable consumption and production, in particular for realizing DG 12. And then ask how can links between SDG 12 and 7 be further strengthened. As mentioned, natural resources are the root of the planetary crisis, and energy is a major fuel for our better life, but also driver of resource extraction. Resources are deeply linked to almost all SDGs, including delivering clean, secure energy through SDG 7. But there are also other implications, like linked to biodiversity. This is one of the reasons why, with co-chair Isabella, we have just delivered Building Biodiversity, the Natural Resource Management Approach think piece. To be truly effective, future actions on biodiversity need to be focused also on root causes in addition to conservation. The problem is that we are using more resources than needed to meet demands and using them in incredibly inefficient linear systems. Most biodiversity discussions still mainly focus on how marginally increase conservation areas, but it's actually more than that. We have to look to a broader questions. To conclude, addressing the challenges we face through natural resources optic provides us with a real message of hope. With the right approach and policies, we could address the challenges together simultaneously, avoid potential trade-offs, maximize co-benefits, avoid future lock-ins. We could also avoid the prevailing silo logic leading to improvements in one area while creating unintended consequences in the others, and also show that we have learned some lessons from mistakes done in the past.
Thank you very much. In the interest of discussion at the end, I won't comment on your very important and rich contribution, but we'll move immediately to my dear friend Ajay Mathur, who is the next speaker, currently the chairman of the International Solar Alliance, co-chair of the Energy Transition Commission, and previously, of course, Director General of TERI, the organization that is hosting this event. Ajay, over to you. You have such a wide variety of hats to pull rabbits out of. Please show us your magic. Over to you.
Thank you. Thank you very much, Suman. And it's a pleasure to be here with all of you. I should correct, I'm no longer a co-chair of the Energy Transitions Commission, but it was a pleasure to work with Adair and his colleagues in that position. As I address the issues that we have here with us today, there are two things which stand out. The first, as you rightly noted in the beginning, were the economic imperatives. And clearly, as demand increases and as more and more of the procurement occurs on a competitive basis, we see efficiencies rising up. Not just in the performance, but also in resource use. That's how you bring prices down and become more competitive. But the second point, which I think you also made and was also highlighted by Adair, was the issue of the politics. And that's what I'd like to focus on as well. Where are we now? Today, we have seen that for the last 4 years, the capacity addition of renewable energy to the grid globally has been far more, and including in India, has been far, far, far more than that of fossil fuel waste. Why is that so? The first issue is that of sheer perceptions regarding the future. I think with I don't know, 36 countries announcing that they would go to net zero between 2040 and 2070. It is the writing is on the wall that investing in fossil fuels means investing in a stranded asset. That's the first point. And therefore, we see the politics reflecting the perceptions that are being created as we speak. The second is the issue of the importance of the availability of energy to each person in the world, and particularly in the developing world. This is important to every political leader in the world, but it often gets subsumed in the larger issue of the haves versus the have-nots. That's where the politics comes in. Let me share with you what our perceptions have been over the 6 months or more that I have been at the International Solar Alliance. The first is that the availability of materials needs to be decentralized. This, I think, in the pandemic and in the blockage of the Suez Canal shows how important it is that countries feel comfortable that they will get the resources that they need, whether the panels or the batteries, when they need it. What it also means is the creation of a large number of centers of supply which are competitive with each other. This obviously means increasing demand in various places, and I'll come back to that. And the second is ensuring that initially the hump of greater costs is somehow met so that the new sources can be competitive. On a political level, therefore, we need these kinds of interventions in place across the world. One of the significant interventions is what we're seeing in India, the production-linked incentive program, the PLI program, where panels or batteries are provided an incentive if they are more efficient than the ones that are in the market now, and two, after they're sold. So it's backloaded and only given if your efficiencies are high enough. So at the moment, we have a scheme for about an additional 8 to 12 gigawatts of manufacturing of annual solar and module manufacturing capacity, and something like 30 to 35 gigawatts of high efficiency solar module capacity and 25 to 30 gigawatts of cell capacity is what has been filed as various private sector organizations setting up this capacity. But what it tells us is that there are all kinds of interesting instruments that can be put into place to decentralize the manufacturing and therefore create a greater degree of confidence that the solar cells would be available. It is equally important that we address the issue of energy security, not in just in terms of imports, but also in terms of the energy that is available to households. This is important because at the end of the day, every political system needs the confidence of the people that they are meeting their needs. This obviously means that you take care of the people who are gaining from the system that exists today, mining coal, selling oil, to those who would gain from the system tomorrow, manufacturing panels, etc. This means that we need to integrate the solar and battery supply systems on one side and the wind supply systems on the one side, and the national systems for the distribution of this. In my view, the new system, and particularly solar, provides a great opportunity in terms of its modularity and consequently its ability to provide resources, electricity resources, in places where it was not available. In the state of Maharashtra, we are seeing that the electricity company says that it costs 7.48 rupees, almost a US 10 US cents to take a kilowatt hour of grid electricity to the rural substations. On the other hand, a company has been procured which has set up about 200 megawatts of capacity, nowhere more than 2 megawatts, 200 kilowatts to 200 megawatts in these rural substations, and they supply electricity there at 3 rupees per kilowatt hour. So 3 rupees and 7.4. What we are seeing is a convergence between the ability to provide electricity in rural areas, the interests of the electricity distribution companies, and the global interests. It is these kinds of convergences we need to find in order for the political support for the changes that we need. The last issue that I would lead to is the resource issue as far as materials are concerned. I think Adair mentioned the issue of lithium extremely well. We have seen the price rises in cobalt. We mentioned that. Again, my point is very similar. We have seen these price rises, short-term spikes in oil and gas as we are seeing in cobalt. But the fundamental change that is happening is that now we are seeing materials being used which have a far greater degree, geographical diversity in availability. So for PV cells, we are seeing organic materials. We are seeing copper zinc tin sulfide materials. We are seeing dye-sensitized solar cells. We are seeing quantum dot solar cells being developed. I have no idea which of these will hit the market. But the point is, the research is pointing in the direction of diversifying the base from pure polysilicon alone. Similarly, on the battery side, we're seeing something very interesting. Today, there is an assumption, at least I had this assumption, that lithium batteries would form the basis of both the storage batteries for electricity generation and the storage batteries for cars and other mobile applications. But it seems they're moving in different directions. We have seen one large Indian company invest a few $100 billion in acquiring battery companies which are based on liquid metals. Sodium ion batteries instead of lithium ion batteries is what they're talking about. Sodium is much more diverse in its availability than lithium is. And it's cheaper as well, but it needs higher temperatures. It's also corrosive. You need to put it in stainless steel containers. Again, what we are seeing is the development of new kinds of chemistries which address the resource issue at its fundamental base. I will not address, but completely accept the point that we need to look at waste disposal. This is an issue of great importance. Collection of waste is important. How you separate out the materials is important. That means that upfront, we would need specifications which allow materials used in batteries and panels to be dismantleable. Only then recycling can occur. We are nowhere yet. But as a Solar Alliance, we are working with governments to see how these things can come into effect. I will end my formal presentation here, Suman, hand it back to you, and I would love to take part in a discussion on these issues. Thank you very much.
Thank you very much, Ajay, for sharing in such detail the area of your expertise. I think there won't be that much time for discussion, but let me just say that we started off by talking about energy security and resource security. I think that implicit in what you have said, we are adding both household or human security as well as national security to the debate and the discussion. Just so that your important insights did not get lost towards the end, I just wanted to say that those are some of the things I heard. But in order to stay approximately according to the time, may I now call on Yuba to take over. Professor Yuba Tokona is currently a vice chair of the IPCC after serving as co-chair of the IPCC Working Group 3. He is honorary professor at University College London, a member of the World Academy of Sciences and the African Academy of Sciences. Yuba, pleasure to have you. Nice to meet you. The floor is yours. You're on mute.
Thank you, sir. Good morning, good afternoon, and good evening, depending where you are physically located and attending this very important event. It's a great pleasure and an honor for me to attend the 2022 World Sustainable Development Summit. I am grateful to the Energy and Resources Institute for inviting me to its flagship annual event. As you know, the Paris Agreement calls for global warming to be kept well below 2 degrees above the pre-industrial levels, while pushing efforts and then to limit it to 1.5 degrees. The Intergovernmental Panel on Climate Change Special Report on Global Warming of 1.5, released in 2018, indicated that limiting warming to 1.5 degrees is not impossible, but it will require, in many parts of the world, unprecedented transitions in all aspects of society, including energy, land, urban, infrastructure, and industrial systems. The global transition toward decarbonization is in particular the energy sector, is a fundamental prerequisite in realizing these major challenges. The world is increasingly committed to decarbonize, as the majority of countries, many cities, and companies have either set or are considering setting system-wide net zero emission targets. Evidence shows that renewable energy, and solar in particular, will play a central role in the global energy transition. Renewables have become, in most cases, the cheapest source for electricity generation, and the electric storage costs have halved within the last 2 years and are continuing a rapid downward trajectory. The required energy security from the massive deployment of renewables is contingent of securing the availability of large amount of critical minerals such as lithium, and then to build and to operate efficiently those clean energy systems. So critical minerals are unavoidable to ensure energy transition, but clearly they have not yet received adequate attention, particularly in developing countries, nor by policymakers in general. Critical minerals are not so integral to the debate on energy transition and or the just energy transition. Among various issues to examine, it is important to ensure that those minerals are not extracted in ways that don't hurt people and ecosystems, and also scramble the resource does not become a race to secure market shares that sacrifices interests of countries and communities where they are extracted. Some of the challenges, such as land grabbing, inequitable redistribution of profits to vulnerable affected communities, and human rights abuse, they will require another much more fundamental and deeper debate that forces us to call for sufficiency and directly question current and project quantity, throughputs, and consumption level. It means critical examination of decades of blend belief in unlimited growth, and rather the formation of different development models. Insight from these debates often open up for majority positive challenges in terms of international collaboration and redirection of priorities. But the perceived tension and scarcity may also lead to unhelpful competition and scramble for resources that sacrifices core premises for well-being and sustainability. The rapid and massive need to reduce emission and moving towards a close to real zero emission as possible requires making sure that energy systems remain decarbonized, resilient, and safe. Critical minerals are essential ingredients for the realization of this ambition. So it is important to look beyond the mismatch between climate policy and energy policy. We must factor in overall levels of critical mineral resources use. The critical minerals such as lithium and rare earth metals essential for renewable energy storage and generation are also used for other things. We then need to figure out, as a global society, what are our priority needs. Technology development may also increase the spectrum of new alternatives of green electricity generation. The rising threat of climate is more and more requiring for the world in moving towards electrification of the economy while decarbonizing their electric power system. This move will lead to an increased demand for non-carbon emitting sources of electricity and energy storage technologies, and in turn will grow the demand for these technologies' component minerals and materials. Meeting the twin goal of energy security and resource security needs a realization upfront that current development models that build on expectation of continued lasting economic growth everywhere is not possible nor likely desirable. Yes, for example, African society will need to grow economically for quite some time, but advanced wealthy economy can't continue this way. The material flow inherently connected with increased consumption, economic growth, and all forms of energy will put too much pressure on our planetary systems. In this context, we likely need to look at convergence in per capita energy use levels, not only to the transition to renewables. Some have been talking about a convergence of energy use levels toward responsible well-being levels. It's time to start looking to this seriously. There will also be need for a global regime for effectively ensure maximum recycling of both critical minerals and other materials. This has been lagging much too long. It's time for the international community to ensure public resources are devoted to build structure and institutions to handle this. And most importantly, to get common and stringent standards, requirements, and regulation. This needs international cooperation and unity beyond what simple country can do. The global stocktake certainly offers an opportunity and then to look at the intended adverse effect of climate measures and could therefore be one important space to advance the kinds of safeguards that are needed for equitable transitions toward the Paris Agreement goals. This must be done across all sorts of fora. It is absolutely crucial to now put full attention and then to ensuring that the transition to renewables and a decarbonized society does not lead to and justify new form of exploitation and environmental harm. The transition is not simply about switching fuels. It must be about the way we organize our economies, set priorities, and define what is real progress and well-being, including scaling down where needed. Thank you for your attention. Back to you.
Thank you very much. Before I ask Shonali, the last lead speaker, may I ask the organizers whether we have any penalty time at all, or do we have to end precisely at 2:30? Can I beg 5 or 6 additional minutes, just so that each of the speakers could answer 1 or 2 questions? Shelley, would you is that okay? Okay. So unless people have to leave, I'll take the liberty provided to me to extend it into extra time. But thank you very much, Yuba, for those thoughtful remarks, and coming as they do from a wise person who sees the reality in Africa. I think these are particularly important. Africa, of course, being both a source of critical materials, but also, together with perhaps South Asia, an area of extreme energy poverty. So the political challenge of balancing these two imperatives is particularly acute, I think, in Africa. But let me finally, last but not least, call on Sonali Pachauri to give her remarks. He is the research group leader in IASA in Austria, a lead author for the IPCC Working Group 3 AR6 report, and serves on the Science Advisory Panel of the Climate and Clean Air Coalition and on the advisory group of the International Network on Gender and Energy. So, Sonali, we look forward to your remarks, wherever you may be, whether it's Vienna or Delhi or whatever. Over to you.
Dr. Berry, and it's really a privilege and an honor to be a part of this illustrious panel. And I'd like to thank TERI for inviting me to be part of this. We've already heard a lot and many important strands of thought on how to better factor resource security issues in discussions around energy transitions and decarbonization. So what I would like to focus on in the next few minutes is really how this all relates to the goal of addressing energy poverty and inequities globally, following on what Yuba also alluded to in his intervention. We know that really addressing energy poverty effectively means considering access to decent living standards beyond mere electricity access or clean cooking access, and understanding the resource needs and environmental impacts of this. We know we live in a world of vast inequalities, and basically access to decent living services globally are unequally distributed. And this is also reflected in the individual contributions to greenhouse gas emissions at a global scale. We know that providing deprived populations with decent housing, nutrition, mobility, and other basic services will require additional infrastructure to be built out, and that the emissions from the production of materials and infrastructure development has increased as a share of total global greenhouse gas emissions in the last 2 decades. So without consideration of the additional material and energy requirements of additional infrastructure needs, we are sure to, of course, increase these emissions further. However, there are huge potentials to reduce the greenhouse gas emissions and other environmental impacts, and technologies available today to increase material efficiencies, particularly in many construction and manufacturing sectors. So understanding the energy and material requirements for achieving decent living standards everywhere is a first essential step to better factor in resource security issues in discussions around energy transitions and energy poverty. The implications of not doing so for efforts to address energy poverty will be dire if particularly distributional implications of transitions, planned transitions, and existing inequities in resource availability and living standards are not accounted for. In particular, digitalization, mobility, and shelter access are 3 important areas that require particular focus. While digitalization has a relatively small material and mineral footprint as compared to mobility and shelter, we know that the electrical and electronic equipment accounts for a sizable share of the total global material flows in copper, in lead, in tin, antimony, and other rare earth minerals. Thus, these 3 sectors, digitalization, mobility, and buildings and housing services, are of first importance when we consider issues of circular economy and meeting the rising needs for these services will require more infrastructure to be built, but this needs to be done in ways that really looks at doing this more resource efficiently and with lower environmental impacts. Beyond the material and resource intensity for infrastructure built out and its emissions consequences, other environmental impacts have also been alluded to by previous speakers, such as those on biodiversity, but also, for instance, we expect significant increases in air pollution like PM 2.5 emissions from mining and smelting that also need to be considered. A shift from fossil fuel to renewable energy, which is critical, as we've heard, for achieving climate goals, will really mean more metal intensive and material intensive requirements for solar panels, for wind turbines, for electric vehicles, and so on. And really, this could mean in certain regions an increase in PM 2.5 emissions from mining and smelting to meet these demands. These could account for up to 10 to 30% of anthropogenic PM 2.5 emissions in many countries by 2040. So, in fact, looking at regions where this might become an issue means really addressing also these broader air pollution related concerns that may arise. Issues of resource security have started receiving increasing attention, but in fact, there's much more that needs to be done. In particular, in the transportation and shelter mobility and shelter sectors, this is really one thing that needs increasing attention. And here again, we've talked about more integrated, more multi-objective and coherent policies. The circular economy concept can be an important one to illustrate the whole life cycle of a product or a service and connect the resource inputs with production, the entire supply chain, consumption, and waste or emissions outputs. There can be possible rebound effects and trade-offs as well. So these have to also be factored in such analysis. In particular, there are three strategies that can be seen as possible ways to address the mismatch between climate, energy, and resource or material policies. One is looking at ways to limit material stock growth through dematerialization, material efficiency, and transition to a more service-based economy. Second, product lifetime extension through repair, maintenance, resale, reuse, and repurposing of obsolete fossil infrastructure, for instance. And finally, waste reduction and management through collection and treatment of systems that optimize reuse and recycling. We know that sustainable consumption and production patterns will be essential to meet growing water, energy, food, mineral, and material needs, and to meet the demands of a growing population and address energy poverty globally. Political efforts really need to shift from increasing efficiency to decreasing overall consumption and from identifying problems to finding solutions. Resource needs for certain parts of the population will rise, but efforts need to consider ways of redistribution and setting sufficiency thresholds to avoid overconsumption associated with affluence and waste. Evaluation of actions, policies, and measures related to the energy system transformation or expansion of infrastructure need to consider the effects on SDG 12 and on sustainable development broadly, and to consider potential trade-offs and synergies and providing human well-being for all without expanding resource and material use extensively or their environmental impacts. I think that circular economy approaches are going to be critical to achieve this and inform more integrated and coherent policies. And I look forward to further discussion on this, hopefully in the next few minutes. I'll stop at that. Thank you very much.
Thank you, Shonali, for packing so much into less time than you were allocated. I'm very, very grateful to you. So we don't have a lot of extra time. So what I'm going to do is, as part of my summing up, just make a few observations on dogs that did and didn't bark, and then I will go back to each one of the speakers and ask them to react to any or all of the points that I might make, perhaps 1 or 2 minutes each. So my first takeaway is that there are at least two very different perspectives on economic growth, which as an economist is for me the God I worship at. There was the view of Janice and perhaps Yuba as well, that frankly, that's the wrong God to be worshipping. And then, but I would contrast that with the perspectives of Ajay and Adair, and to some extent Shonali as well, which are that, look, there are a lot of people in the world who have legitimate needs for material output, and the point is to provide that with less damage. I mean, the focus was really on energy security, although we've started to talk about resources more broadly. So I just wanted to say there are these two perspectives, and I'm pleased that these perspectives have emerged in the course of this fascinating panel. The second point I would make is that I said that there are substantial technical solutions. So the issue is really the political how, and the issue of, how to communicate this nationally and globally is something that Adair said that he might want to address. The third issue, which is linked up with the communications issue, it seems to me, is the various distributional elements of this. Distributional globally, distributional across the corporate sector, whether you should be taxing windfall rents or whether you should allow windfalls to accrue to expand supply. The question of, the resource footprint of the rich everywhere, not just the rich in the rich countries, but the rich in poor countries as well. So, and obviously the link between, as it were, financial power and political power, which I think is coming under a great deal of scrutiny in the United States at the moment. So if the underlying issue is inequality, inequality is the problem that politics was invented to deal with. So, do we have something to say about the political system which might actually address the issue of inequality? And finally, because I don't want to overload this, is very different views of the role of the state. I mean, nobody actually said it, but some people could be interpreted as feeling that you basically need strong state direction for such a radical shift. And yet there was also a belief that decentralization may be the route to go. And, let us remind ourselves, since we're in India, of Gandhiji's kind of vision that basically self-sufficient rural societies and, that they did a pretty good job of the circular economy, and that it is what has happened since, which has turned out to impose an impossible burden on the planet. So thank you for stimulating all this in me, and I think just to give Shonali a rest, let me go 2 minutes each, please, in the sequence, starting with you, Adair. Comments on what I've said or anything you want to add in response to what your fellow panelists have said.
Thank you, Suman. You raised this question of how do we communicate what really matters? And I think the crucial thing is to always keep coming back to fundamental facts. Let me give you an example. At the ETC, we believe that we will need to produce by mid-century, let's say 500 million tons of hydrogen for the global economy, rather than 100 million today, with 80% of that coming from the green electrolysis route. And when I've said that on various forums, people have said, but what about the natural resource requirement? What about the water that you need for electrolysis? But then run some numbers. Every ton of hydrogen requires 9 tons of water. If you know your molecular weights, you can pretty quickly work that out. So if we have 400 million tons of green hydrogen, we need 3.6 billion tons of water. Let's call it 4 billion tons. That's big. It is an area of 4 cubic kilometers, if you could think about that, a big space. But let's compare it with total global water use, which is 4 trillion tons, not 4 billion, it's 4 trillion, of which 90 to 95% is being used in agriculture. The use of water in agriculture is 3 orders of magnitude bigger than the use of water for all the green hydrogen that we will need. The use of water in green hydrogen is a trivial problem. And I make this point to illustrate a wider problem. We talk about planetary boundaries in a general sense and the horrors of deforestation. And yes, there is a contribution to that of mineral extraction. Sometimes when we build cobalt mines or nickel mines, they will go into the forest. But let's be clear, 95% plus of all our planetary boundary problems, and in particular our destruction of forests with the CO2 impact and biodiversity, is food and fiber. And it's fundamentally because food and fiber, the way we do it in the world at the moment, is a stunningly inefficient system, particularly if we eat meat. When we run a photosynthetic process to produce vegetable protein, we turn about 1% of the sun's energy into energy within the vegetable matter. That compares with 15 to 20% when we build a field of solar panels. But when we then decide that we want to eat meat protein, we turn that vegetable protein through another processing plant called the cow, which is only 4% efficient. And it is this stunning inefficiency of the photosynthetic and the meat production system by animals that means that if 8 billion people want to eat meat, we will destroy the planet. And let's be clear, that is a problem 100 times bigger than all the nickel and all the copper and all the lithium and all the cobalt in the world. So we absolutely must make sure that we know where the big problems are that we need to solve, and where there are other ones where, yes, we need to do as best as possible, but we will not go beyond planetary boundaries because we're taking too much copper out of the earth. We will if we eat too much meat, the present way we produce it.
Okay, well, I hope you in the Lords you're making that point aggressively and continuously. Janice, over to you.
Saman. It's actually, I would agree with everything what Adair has said now. Indeed, there are a bit 2 different perspectives, but what is common that we actually have the same goal, which is good. So the first fact which I would underline is that the irrational overuse of natural resources, which we have developed with the prevailing economic model, it's causing today the overconsumption, in particularly in high-income countries. And I think that's the fact. And this is one of the main reasons why actually we are overshooting the planetary boundaries on many levels. Climate change, it's an important part of that, probably most important, but it's not the only one. Also, the others are important. So we have to use natural resources rationally and in a responsible way. And some of them are absolutely limited. If somebody is not believing that, ask our African colleague how much every drop of water matters for them, or how much every hectare of fertile land matters for them. These are important issues which we can't deny. And all at the end, it's about meeting human needs in the most efficient and least damaging way. And of course, fixing the inequalities which are currently existing. Because absolutely in low-income countries, their human needs are far from being yet met. And we understand very well that there will be additional resource needs. But for that, we need to focus on the overall economic systems to not repeat some of the mistakes which were done in the high-income countries. And finally, when we talk, by the way, I think really that energy community is doing an impressive and incredibly important job. And the angle through which I tried to light the light on that was just that there are potential solutions existing which are coming also from the resource angle, which are currently not taking fully into account, which could help actually the energy community, if I can say so, to solve their problems better and quicker. It's just a kind of offer of cooperation where I firmly believe that at the end of the day, not asking how we are managing our economics will not help us really do the change we need.
Ajay, your reflections on the issues I raised and or the other eminent speakers have raised, recognizing that we're in extra time.
Yeah. So, Suman, the point that, first of all, I am in great sympathy and on the same side as both Adair and Janice. The point that I'd like to make is that in all of these trade-offs, it's never a this or that. It is a compromise. The biggest compromise that we have to do is on intervention versus the free market. What has happened? What has happened is that we now need interventions in different places and at different scales. So let me give you an example. Yesterday, the model was that we would set up large fossil fuel-based power stations and have a grid that takes electricity everywhere. We've already moved into a system where we've delicensed much of it. The only part which is licensed in most parts of the world is how the electricity reaches your home. Well, we might be moving into a system where that is not regulated, but what is regulated is the quality of supply. This is important because the quality of supply could include where the electricity is coming from, whether it is renewables or whether it is coal. Similarly, the regulation of production, whether it is batteries or solar panels, could become important in ensuring that the waste disposal occurs and in ensuring that efficiencies continue to rise. The short point that I can leave you with is not that we cut meat out completely, but if we can reduce it to 20%, the world will be better off. Thank you.
To Yuba, any specific political challenges from what you see in your continent that you'd like to share with our audience?
I think that I do agree with everything that has been said, but what is important is that context matters. When we discuss all those different issues at global level, we overlook the problem of billions of people. In the morning, I was about not to participate to the event for a simple reason, because I and I are not living the same problem or because I had blackout this morning. And I sent an SMS to say maybe I will not be able to attend the event because of blackout. And then the problem is that we do have all the technical solutions. We do have a political platform. We do have business cases and then to address fundamental issues, but we are completely blind. The whole discussion on energy transition, and then it became something as normal, while in the poor countries in Africa, it is not an issue of transition, it's an issue of jump-starting. Because the system does not exist, and then we can build the system. This one element, and then we can move away from The dominant system, we are not questioning it, that is the supply-oriented system. And then we can do it demand-oriented system. One fundamental problem, and then Shonali knows better than I on that issue, no one at the global level is talking about phasing out the use of charcoal and firewood for cooking. And that related to all aspects that has been addressed by all the speakers and directly. And then this fundamental element, none the discussion on energy transition at all addressing it. But that if we have the possibility to do it by 2030 or 2040, and that will be a completely game changer. I think that Shonali will develop and then on those different issues. I think that it is important to keep in mind context matters, and then we cannot have a discussion at the global level, and then we have to address it at the regional level, at the local level, and then in order to be able to bring all the changes we have in mind. And sorry to be too long on that.
Not at all, you were. It's an important perspective, including in parts of India, although progress has been made. Finally, I'm told that the referee's whistle has been blown, but it would be discourteous. You have the final word. I will thank all of you now, so that as you end, Shelley can close down the session. You have the final word.
You, Suman. And I think we've heard many different perspectives, but I think we're all kind of agreed in a way that, we can't use the old growth paradigm as it has existed. It has to be growth with redistribution, and it has to be growth with considering really the whole life cycle of what we are doing, and thinking about those who have too much and those who have nothing. So I'll end with that. I know we're being mindful of time, but I've really enjoyed being part of this panel, and thank you for inviting me once again.
Well, the invitation came from TERI, so whoever it is who gives us the signal that we go offline, Shelley, over to you.
Yes. Thank you so much. Thank you so much, everyone. And I think even it was an enjoyable session for everyone. And we hope that we can have a longer session next time, and that too in person. So thank you again, and we'd like to close this session, please. Thank you so much.
Right. Bye-bye, all.